Hi all, welcome to Heights to Five. Today we are discussing about the exercises included in 1.2. That is the first chapter is number systems. In that session we discussed about irrational numbers in the previous class, and today we are discussing about exercise 1.2. In previous class we discussed how to represent a rational number, root 2, root 3 in number lines, and many other problems. Today we are going through the exercise problems. The first question is, state whether true or false. State whether true or false. First statement is, every irrational number is a real number. Every irrational number is a real number. Is a real number. Irrational. What is an irrational number? Irrational numbers are numbers which are not written in the form of p by q, where q not equal to 0 and p and q are integers. In previous class we discussed thoroughly about this. Once again I am telling, irrational numbers are numbers which are not written in the form of p by q, where q not equal to 0 and p and q are integers. Examples are, example 4 irrational numbers are root 2, root 3, pi, root 5, 0.10, 110, 1110, non-terminating numbers like that. What is a real number? Real numbers are collections of rational numbers and irrational numbers. Real numbers includes all category of numbers which are rational and irrational. What is a rational number? A number which can be written in the form of p by q. Irrational numbers are numbers which cannot be written in the form of p by q. Real numbers include all these kind of numbers. So we can say that the statement is true. That is, every irrational number is a real number. Every irrational number is a real number. What is the second statement? Second statement is every point on the number line is of the form root m, where m is a natural number. M is a natural number. Once again, the statement is, every point on the number line is of the form root m, where m is a natural number. Consider a number line. Previous class we also discussed about what is a number line and how to represent. Positive integers are, it includes all kind of numbers. Number lines includes all kind of numbers, positive integers and positive and negative values. Positive and negative. Positive numbers like root 1, root of 1.1, root of 1.2. Number lines includes positive and all positive and negative numbers, but we can't represent negative values like this. Negative values like this. So these are complex numbers. Negative root values are complex numbers. We can't represent this type of numbers in number line. So the given statement is false. Once again, the number line includes all type of numbers, real numbers, rational numbers, all kind of numbers, but this kind of numbers we can't represent it in number line. So we can say that the statement every point on the number line is of the form root 10. So this is a false statement. Next go to the third statement. Third statement, every real number is an irrational number. Every real number is an irrational number. Consider irrational numbers are in the form of irrational numbers. Every real numbers, consider the irrational numbers. Irrational numbers are in the form root 2, root 3, etc. But real numbers consist of numbers. Real numbers consist of numbers like 2 by 3, 3 by 2, 3, etc. So this statement is false. Every real number is an irrational number. The statement is false. But the reverse is correct. Every irrational number is a real number. But this statement, every real number is an irrational number, is a false statement. Okay. Next go to the next problem. Question number 2. Question number 2. Are the square roots of all positive integers irrational? Square roots of all positive integers irrational. If not, give an example of the square root of the number that is a rational number. Once again the question, are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. That is, we have to prove this statement by giving an example. So, are the square roots of all positive integers irrational? Consider some examples. Root 2, root 3, root 4, root 5. Root 2, root 3, root 5 are, these cases are irrational numbers. But this is not an irrational number. Not an irrational number. The result is plus or minus 2, which is a rational number, which is a rational number or integer. Therefore, we can conclude that the square roots of all positive integers are not square roots of all positive integers are not irrational. From the examples, it is clear that root 4 is not an irrational number. It is a rational number or an integer. Therefore, we can conclude that square root of every positive integer is not an irrational number. Next question is, show how root 5 can be represented in a number line. How root 5 can be represented in a number line. Okay, in previous class we go through the methods how to represent root 2 and root 3 in a number line. Here we are going how to represent root 5 in a number line. First we have to draw the number line. The previous class itself, please go through the previous calls also. Here measurements are taking 2 centimeter as a single unit. 2 centimeter as a single unit. 1, 2, minus 1, minus 2. This is a number line. And here we are taking 2 units. That is, we represent the second point as A. Second point as A. And we are drawing a perpendicular from this point A by taking a single unit. Don't forget single unit. Here we take 2 units from 0 to 1 a single unit, 1 to 2 a single unit. So 2 units are taken here. Here a single unit, and we are joining this point with the point, origin point, and mark this point as B. According to Pythagoras theorem, what is OB square? OB square is equal to root of OA square plus AB square, which is equal to root of 2 square plus 1 square, which is equal to root 5. OB is equal to root of OA square plus AB square. So root 5, we can take this value as root 5. So take the measurement root 5, that is OB, and draw an arc to the number line. Mark this point as A dash. This is root 5. This point is root 5. That is from 0 to A dash. The length is root 5. 0 to A dash. We measure this as root 5, and we take this value and mark a point on this number line. This is the point root 5. So here we discussed how to draw root 5 or mark root 5 on a number line. Here we takes two units as a measurement, and here single unit. This is a right angle, so we can take Pythagoras theorem. By Pythagoras theorem, we get the value OB and take this length and mark a point on the number line. So today we discussed a lot of problems on irrational numbers, which is which is mentioned as 1.2 in textbook. So thank you for watching. Subscribe and share for new videos.